Welcome to part 2 of our 10th tutorial. We're working on a number guessing game, and here we're going to try to find a way to guess the user's number in less tries than the random implementation we have seen before would allow us. So the random implementation would need up to the maximum amount of possibilities. So if you were to say, think of a number between 1 and 20, it would take you up to 20 tries to find the user's number. And now we're going to look at another way to solve this issue. So we're trying to find a way. We're trying to find an algorithm, and I'll define algorithm in a bit. But essentially, we're trying to find a way to make this program work and not require up to 20 times to find a user's number if we give them the possibilities of 1 to 20. But how do we do that? We're asking the user, is this your number? We're guessing a number, let's say 5, and we're saying, is this your number? If they say yes, then we found it. If they say no, then we have absolutely no knowledge. We've gained no further knowledge on approximately what their number is. So as a child, you probably played a game where you're trying to find something, and those around you will tell you you're getting hotter, you're getting cooler. So if you're going close to it, even though you don't know what it is, they tell you they tell you hotter, and if you're going away from it, they tell you cooler. So they give you some sort of direction. With the yes or no, we have no direction. We simply know that it's not the number the user is thinking of. So what we're going to do is we're going to change the game slightly. We're going to change the question slightly so that the user gives us the direction. So in the program, instead of saying, is your number this, yes or no, why don't we ask, is it your number? Yes. Is it higher or lower? So if we guess 10 and your number is not 10, well, is your number higher or lower? Because this would give us a direction to go on. So if I were to guess 10 and you said higher, then I'm not going to guess 1 to 9. You already said higher. Now let's see how that would work. First of all, we're not going to do this randomly, so we don't need to import this number. We're going to go back to 1 to 20 to illustrate this. We can change that later. We no longer need the guesses list because we're not doing random guessing altogether, right? And we don't need this. We don't have the list actually, so we can't even use it. Right. So now, how would we do that? Like I was saying, if I were to guess 10 and the user was to say higher, then I'm obviously not going to guess between 1 and 9, right? If they were to say lower, I'm not going to guess between 11 and 20. So you can see here, the best thing to do is to actually go right in the middle. So if the search space, for me, if the possibilities are from 1 to 20, so that's my search space of numbers, I go right in the middle and I say 10. So by default, or the first time that is, I'm going to say my guess will be the minimum plus the maximum divided by 2. Now, in Python, note that the single slash division will give you non-integer numbers, or not necessarily integer numbers. So in the first time, when it's 21, minimum plus maximum, divided by 2, it would give you 10.5. And we didn't tell the user to think of those kind of possibilities. So what we will do is we will use the floor division, which will give us 10. Okay? So we guess 10. We say, is this your number, higher or lower? If they say yes, this is my number, nothing changed, we found it. Now if they say no, we have to check what they said. Did they say higher or did they say lower? Now if they said higher, like I said, if they said higher than 10, then I no longer want to consider anything less than 10. So what I'm going to do here is, the next time I go in the loop, I'm only going to consider 10 to 20. So the first time it was 1 to 20, the second time it's 10 to 20. Or if they say lower, it would be, the second time would be 1 to 10. So if they said higher, I will change my minimum number to be equal to the guess. And if they said lower, my maximum number now would be the guess. And if they say something else, and you will notice here, I'm being specific instead of doing if else, because here we have more options. And so we have to check which one. If we don't know what you have entered, we can't simply process it. So we're going to say, we do not recognize what you entered. Please try again. And this would just go back, print the same guess again, and ask the user the same question. So what I'm doing here is, if I guessed 10 on my first attempt, the user said higher. Now the minimum number is 10, and the second guess would be 10 plus 20 divided by 2, which would be 15. If they said lower, the maximum number would now be 10, so the next time it would be 1 plus 10 divided by 2, which would be 5. So I'm cutting my search space, I'm cutting the number of possibilities by half every time. Okay, let's save that and run it. So think of a number between 1 and 20. 12 again. So is it 10? And now I have to go higher. Is it 15? Lower. Is it 12? Yes. So it found it in 3 tries. Let's go back to the program. Let's try again because I want to illustrate something here. And this is something that I'm sure you would know about this program, is it's very predictable. It will guess the numbers in exactly the same way every time. So if it took 3 times to find 12, it will always take 3 times to find 12. Not like the random one where it could be the first attempt or it could be the 20th guessed number. So this works great, but it does have issues. It does have bugs, and so we're going to look at that next. To find bugs in your code, you can take a look at it and review the code and see if you can spot it. But if not, what you have to do is you have to test and see where the code fails or it doesn't work as expected, and then try to debug, find out why the problem's happening, and fix it. And when you're testing, when you're looking at a range of numbers, if this is basically your input, so the input here is numbers between 1 and 20, right? So what you do is you test the regular cases, which in this case are in the middle, and you test what in programming we call edge cases. So the edge cases are the outliers. In this case, if my range is 1 to 20, 1 and 20 would be considered edge cases, and 2 to 19 would be called normal cases. So I would test the normal cases. I would test my 2 and 5 and 10 and 15, but I definitely have to test 1 and 20. So you don't have to test all the numbers between 2 and 19, but you definitely have to test the edges, right? Because usually, if there is an issue, it would be on the edges. So we've seen that 12 works. We can try another one. Let's test with some other numbers. Let's test with 17. Higher, higher, yes. Now let's test the edge cases. And you can when you run this program, you can test as much as you want from 2 to 19. But again, usually if you've tested a few, that would be good as long as you test the edge cases. So my edge cases here, because my range is from 1 to 20, my edge cases would be 1 and 20. So I'm going to start with 1. Let me see if that works. It does. So now I'm going to test 20. 17, 18, 19, 20 doesn't work, right? Because I go higher, 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 I get to 19, and now it gets stuck at 19. So now I go yes to exit, but I know that I have a bug. So I can go back to the code. Now I know that I have a bug where it doesn't show 20. So I can try to guess it by looking at the code. I can try to sort of analyze the code and see why that's happening. And a lot of the times that works great once you know at least what the behavior of that bug is. So basically it's showing me 1, it's showing me 2 to 19, it's not figuring out 20. But if not, I have to try to debug, and the way to do that, or a way to do that, is to use the print statement. When you're in more advanced and big programs and you have an integrated development environment, you can use a debugger, but for our small program, the print would do. So I'm already printing the guess, so I know what the guess is. What I don't know is my minimum number and my maximum number. Because remember here, I'm changing them. In the previous implementations, min and max numbers were not changing, but in this one, I'm changing it on every time. So I'm going to print my min and max, and I'm already printing the guess, so now I have all the numbers, or I will see all the numbers. Max, so my minimum and my maximum, I print these. Let's run this now. So min 1, max 20, number is 10. I'm going to go higher. 10 to 20, the guess is 15, higher. 15 to 20, the guess is 17, higher. 17 to 20, the guess is 18, higher. 18 to 20, the guess is 19, higher. So see here, minimum was 18, maximum was 20, my guess was 19. I said higher. It increased the minimum to 19, the maximum is 20, but the guess is still 19. Let's say higher again. Now you can go higher as much as you want. The minimum will still be 19 and the maximum will be 20. So let's go back to our code and see what's happening. So I know that if I have 19 and 20, my guess will be 19. Well, yeah, I know that because I'm using floor division, right? So see, now I figured out why it's not displaying 20, because it got to 19, and 19 plus 20 is 39, floor division by 2, so my new guess is 19. And because I said higher, it says minimum number is equal to guess. Well, minimum number was already 19, and the guess is 19, so really that doesn't change anything. It goes again into the same cycle. So now I have to fix that. There are different ways I can fix that. I can say if minimum number is maximum number minus 1, and if you say higher, then I go to maximum number. But perhaps a better way to fix it is to look at what we're doing here. See, if the user said higher, if I guess 10 and the user says higher, I'm setting my minimum number to 10. But the user already said higher, so I know it's not going to be 10, so why did I include 10 in the new search range? So in fact, if the user said higher, if I guessed 10, my new minimum number should be guess plus 1. It would be 11, because 10 is not a possibility anymore. The user already stated it's higher. Same thing the other way around. If I guessed 10 and the user said lower, why should 10 be the maximum number? It should be 9. Guess minus 1, right? And that would resolve my issue, because if I said 19, or when we say 18 and it's higher, it becomes 19. When it's higher, it becomes 20. Let's see how that works. So let's save that and run it again. Now I can go higher, 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 and now it gets to 20. And the reason is, when you said higher than 19, I didn't set my new guess minimum number to 19. I set it to 19 plus 1, which is 20, right? And now I find 20. So I say yes. So this is great. We fixed one bug. So when we change code like that, we have to make sure that the other tests we ran through, the tests that were working before, still work. So let's run this again. We tested it for 1, remember? And we changed how the minimum and the maximum changed. So maybe that broke the 1. Let's try that. 10, lower, lower. So we know that the 10 works. We can try other cases between 12 and 19. We're going to find that it works. So that's great, and this is how we debug our code. Let's run this again and go through what we've seen in the previous attempts with our program. What if the user keeps on saying no? We found 20. User still says no. Okay, so we don't fail, which is good. We don't display numbers that are outside the range. That's good, but we're still going, right? Let's try it again with 1. So previously, the user could only say no, but now they have 2 options to say no, higher or lower. So if they keep on saying higher, they get to 20. If they keep on saying lower, well, hold on, now they get to 0, and that's a problem. Right, so let's go back to our code and fix that now. So now we've fixed the fact that we can find all the numbers in the range fairly quickly, consistently, but we have to check, basically, if the user is trying to play tricks on our program. So, as usual, we're going to check after this if statement, because if the user says yes, then they've said that they found it and we're done. Now if they say no, and in this case, if they say higher or lower, we have to check if we've run out of possibilities. But how do we do that? We do that by checking the minimum and the maximum. In this case, we're changing the min and the max. So if we reach the case where minimum is equal to maximum, which means this is the only number left in our search space, if the user still didn't say yes, then that means we are no longer playing the game because we've run out of possibilities. So if we reached the case where the minimum and the maximum are now equal, then that means, and again, the user didn't say yes, because if they did, we would have exited here. Then here we know that we have run out of possibilities, and we break. And so here we can try. After the 1, if you said lower, it says we've run out of possibilities. Let's try again with the 20. And again. So this is great, and this is how we debug code. And this, like I mentioned more than once so far, is called a binary search algorithm. The really cool thing about this is, now that I have something that allows me within 5 times to find the user's number for a range of 1 to 20, I can try higher ranges. I can go 1 to 1,000, because each time I'm cutting the search space by half. I can go to 1 to 1,000,000. And in fact, if I change my maximum number to 1,000,000, this program like this will find the user's number in 20 times or less for every single possibility from 1 to 1,000,000. So let's try that. Let's think of a number. Let's say 630,732. So 630,732. Remember that. We start with half a mil. We say higher. Is it 750? Lower. We said 630 something, right? So it's higher. Lower. 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 It's at 630, right? So now it's higher. 630, 732. So it's lower, higher, higher. 732 is lower, higher. And there you go. 630,732 in, how many are these? 10. In 18. So in 18 guesses, we found 630,732. And I'm willing to bet you anything that you can try all the possibilities you want from 1 to 1,000,000, and this program will find it in 20 times or less. In fact, in 30 times or less, it'll find all possibilities between 1 and 1,000,000,000. That's a really cool and neat trick if you play it on someone who doesn't know. Now, I did leave one little bug in the code, and that bug is related to the case where we go lower, 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 and it wouldn't stop at 1. It would actually go to 0, and it just would continue giving us 0 as the option. Now, we did say we fixed it, and in fact, we did fix it. We fixed it for the range of 1 to 20. So basically, we did a fix in the code, which you saw, and for numbers between 1 and 20, we went lower, 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 and it says we've run out of possibility. And you could actually even try that for 1 to 1,000,000 and it would work. So the bug is a little bit subtle. It only shows up for certain ranges. So 1 to 20 would work, 1 to 1,000,000 would work. A whole lot of different minimum and maximum numbers would work, but some would not. So I'm going to show you the behavior for a minimum number of 1 and a max of 23. So between 1 and 23, we go lower, 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 lower. So as you can see, we get to 0, not, it doesn't stop at 1, it keeps on going, and you could go lower all you want. It would show you 0 as the option. Okay, so this is what I was talking about before as a partial fix. So the fix we did worked for a whole lot of ranges, and we might have missed it if we don't try enough ranges. So this is a challenge for you. I'd like you to, when you get to this point in the program, try to basically find why this bug is happening and hopefully fix it. Now, I will be posting all the different versions of the number guessing game on my blog, including the final solution with the fix to this issue. But hopefully you will try it on your own, and this will give you a great learning exercise, even if you don't actually fix it on your own. So just by trying, even if you don't get to the solution, it's actually a great learning experience. Again, the solutions will be on my blog, and hopefully you will give them a try. I hope you found this interesting. The algorithm we just saw, as I mentioned, is called binary search, which essentially cuts your search space in half each time. Now, an algorithm is a set of rules followed in calculations or other problem-solving operations by a computer. In our case, the set of rules was, if the user said higher to our guess, we discard the lower half of the search range, and if they said lower, we discard the upper half. Of course, there are other algorithms out there, and we may get to some of them later on in this tutorial series. These algorithms are the engine behind the games you see, and I hope that this gives you enough motivation to keep going into the world of programming. Next time we're going to look at user-defined functions, so we're basically back at looking at programming concepts. Until then.